Hello, so in this video we will talk about how to find the expected value of the multinomial distribution. Okay, so as an introduction, what is a multinomial distribution? So let us consider we have an experiment that can result in R possible outcomes. And probability of the experiment resulting in the ith outcome is Pi. So this is Pi. Okay, and the experiment is performed n number of times, and each experiment is performed independently of all the other experiments. Okay, and then xi be the number of times the outcome I occurs. Okay, so I can be any number between 1 and r because we have 1 and r number of outcomes, and xi can be any number between 0 and n. So the worst case is that xi never happens at all in n tries, and the best case is that xi happens every time for n tries. Okay, and then we have a probability that x1 occurring x1 times, x2 occurring x2 times, and xr occurring xr times. That probability is given by the multinomial distribution, and the PMF of that distribution is given by this expression. We have n factorial divided by x1 factorial, x2 factorial up to xr factorial times p1 to the x1, p2 to the x2 up to p to the pr to the xr. And since it is a PMF, so this means that the sum should be equal to 1. Okay, now what is our expectation? So what we are interested in, e to the xi. Okay, so without loss of generality, we will find e of x1. Okay, so e of x1 we are going to find. So what is it? For the definition, so expectation of x1 is x1 times probability of x1 is equal to x1, and then this can be x1. What is the range of x1? From 0 to n. But for x1 is equal to 0, this goes to 0, so I can easily say this is equal to x1, this is equal to 1 to n x1 p to the x is equal to x. Now I need this probability, but I only have the joint probability. So what do I have to do? I have to marginalize this distribution with respect to all the other variables except x1. So I will do this guy. I'll say e of x1 is equal to I is equal to 1 to n x1, and then p of x1 is what? x2 up to xr, p of x2 is equal to x2 up to xr is equal to xr, correct? And obviously x2 plus x3 plus up to xr, this should be equal to what? N minus x1. Okay, so this is my situation here. Okay, now I plug in the values. I have I is equal to 1 to n x1. Okay, and then I plug in this guy. I say x2 to xr, and same line here like this here. Okay, so I'm just saving some space here. Okay, so then this guy, then I will say n factorial over x1 factorial up to xr factorial times p1 to the x1 up to pr to the xr, correct? Okay, so can I now bring this x1 here? Okay, so I have e to the x1, this is equal to I is equal to 1 to n sorry, xi is equal to 1 to n. Xi is equal to 1 to n, so this should be xi, okay, and this should be xi, okay, or x1 actually, x1, and this is x1. X1 is equal to 1 to n, okay, and then I can say x2 up to xr, and then I can say n factorial divided by x1 minus 1 factorial x2 factorial up to xr factorial. Okay, and then I can say p1 now I can actually say p1 and then p1 x1 minus 1, then p2 x2 and pr xr. So let me clean this a little bit. So this is x1 minus 1. Okay, okay, let x1 prime, this is equal to x1 minus 1. Okay, and then x2 plus x3 plus xr plus x1, this is equal to n. So this means x2 plus x3 plus xr plus x1 prime, this is equal to n minus 1. Correct? Okay. Okay. Then I have again e to the x1. So what I'm going to do is I'm going to bring this p outside first. So p1, and for this n factorial I'm going to bring this n outside and change it to n minus 1 factorial, and I will say x1 prime, this is equal to 0 to n, and then I can say x2 up to xr, such that this thing, so this is a 0 here, this whole thing I can say x1 prime plus up to xr, this is equal to n minus 1, and then I can say n minus 1 factorial divided by x1 prime factorial x2 factorial up to xr factorial. Okay, then times p1 to the x1 prime p2 x2 up to pr xr. Now compare, now I can say I can combine these two summations, so I can just say one summation, so x1 prime x2 up to xr, where x1 prime plus x2 prime x2 plus up to xr, this is equal to n minus 1, and then I can just bring this guy here, but this, and then I have n times p1 outside. Okay, now this guy is what, this summation is what, so this summation is 1 because of here. Now the only thing which changes is the parameter has changed, so n in place of n we have n minus 1, so actually we are just performing the experiment n minus 1 times, and we have the probability of x prime is equal to x1 prime is equal to x1 prime, right? So the only thing which has changed is this n1 n to n minus 1, and the summation of all the variables, the values they can change, they can take, the summation will always be equal to this numerator here. So this means that this guy is, this whole summation is 1, and our summation, our expected value is n times p1. So this means that e to the xi, this is equal to n times pi. So this is the expected value of the ith outcome, or we can say the number of times the outcome I occurs, that random variable, because that random variable is related to the multinomial distribution if you marginalize the PMF. Okay, so this is it about the expected value for related to a multinomial distribution. Hope it was easy to understand, and thanks for watching. Hope you liked the video.